Let's do question 2. We are doing these questions as fast as we can. This is not even hard, all right? Question 2, what do you want, my friend? It says, okay, one-sided limits. Yes, we know that piecewise functions and functions that involve a modulus when you want to find the limits, you have to come from one side at a time. So when we say one-sided limits, it's either the limit exists when you come from only one side, or we are trying to solve a limit that is piecewise. So we have to come from one side at a time. So we'll be finding one-sided limit at a time. So we find the limit from the left, and that is called a one-sided limit because we are only coming from the left. Then you find the limit as you come from the right. That is also a one-sided limit because you're only coming from the right. Then you now compare the two. If they are the same answer, then that means you'll be having this overall limit. So here, what are they saying? Graph the piecewise and use your graph to find the limits if they... Okay, let's graph the piecewise function. This is not hard. We know piecewise functions have parts, right? So we are graphing this. Let's see what we are graphing. This function is x squared if x is less than 2. So when x is less than 2, it will be an x squared graph, okay? Not even a problem. And then it is 6 minus x if x is only greater than 2, okay? So when x is greater than 2, then it becomes 6 minus x. Okay, so now let's put it. So we are saying now for x less than or equal to 2, this graph is x squared, okay? This graph is the graph for x squared. And don't forget what the graph for x squared is, okay? It's just like this. This is the graph for y equal to x squared. It does this. It's a curve like this, okay? And here, this would be 1 and 1. Then this would be 2, which goes to become 4. And if you follow it, this 4, it also goes to negative 2. Then here we'll be having 3. Okay, sorry, this is wrong. You can say, if I come down like this, this will be 3. And yet on the y-axis, you put 3 squared, which is 9. Okay, so that's what happens. And it will be going to minus 3 again, that 9. Anyway, let's see, we'll put it. Now, how do we sketch? We only want like 3 points, okay? 3 points, yes. So let's say x and let's put f of x, okay? 3 points, or we can put 4 points. Right, now remember we are doing x less than or equal to 2, right? So we can start from what? We can start from minus 1. We can do minus 1. We can do 0, okay? So we're going to do minus 1. We're going to do 0. We're going to do 1. Then we're going to do 2 because it's less than or equal to 2. So we're going to do these ones. Now let's find for x less than or equal to 2. Remember that f of x is equal to x squared, okay? It's equal to x squared. So if you want to find the things, you'll be saying f of negative 1 will be, instead of x squared, it's minus 1 o squared, which is going to be 1, okay? Because you would have put remind us below the table that f of x is equal to x squared because you are dealing with x less than or equal to 2. So you'll be saying f of minus 1, this is going to be minus 1 squared. This is going to be minus 1 squared is just a 1. Then we say f of 0, this is going to be 0 squared, which is just going to be 0. Then f of 1 is going to be 1 squared, which is just a 1. Then f of 2 is going to be 2 squared, which is a 4. So this is going to be, we said a 1, a 0, a 1, and a 4. Okay, so no problem. Now let's do for the other one. We say for x greater than 2. Okay, we're saying f of x. Remember, to put the table, we need the table also. Then we can find those values. So we can say now, you can put here to say, for x, you can say f of x is equal to, what is it? 6 minus x is equal to 6 minus x, okay? Which is like minus x plus 6, okay? We can say f of x is equal to minus x plus 6. We have rewritten it because the x is the one which is negative, and then this 6 is a positive, so it ends at the end. Why did I do this? This tells you where it passes through the y-axis. When x is 0, this would be y would be 6. But unfortunately for us, although we can't ever go to x be 0 because we're only dealing with x greater than 2, okay? But ideally speaking, so now let's put x and let's put f of x. Now let's put values of x which are greater than 2. 3, we can't put 2 itself because we are only taking greater than 2. So 3, 4, 5, 6. Okay, can even put up to 7. So now we remember that we are now saying f of x is equal to 6 minus x, or minus x plus 6, whatever. So if it's 6 minus x, you can say f of 3 is equal to 6 minus 3, which is just a 3. Then f of 4 is equal to 6 minus 4, which is just a 2. Then f of 5, it will become 6 minus 5, which is a 1. Okay, then f of 6, 3, this is f of 3, f of 4, f of 5, then f of 6, this becomes, instead of 6 minus x, okay, because we have the f of x here, this becomes now 6 minus 6, which is 0. Then f of 7, this is going to be 6 minus 7, which is equal to minus 1. And these are the values. So let's put the thing in the table. F of 3 is a 3. F of 4 is a 2. F of 5 is a 1. This is a 0. Then f of 7, we saw that it's a minus 1. So now let's put the thing. Let's sketch. Let's sketch. This minus 4. Then here we have 1, 2, 3, 4, 5. Okay? Now, what are we going to do now that we have reached here? We are going to put the y values. Y values, what were the y values we were getting? We were getting these f of x values. We can see that there is a, sorry, when you put it, it was a minus 1, not a minus 7. So this I can see it's from 3 to minus 1. On this other table, it's from 1 to 4. Okay. So this is what we'll be having. Okay. 1, 2, 3, 4. Minus 1, minus 2. Like this. So now let's put the points. Let's put the points. We start with the x squared one. Okay. We have x values, which is x minus 1, y1, then 0, 0. So x minus 1, y1. So it's going to be here. Then 0, 0 is going to be here. Then we say, what is it? 1, 1, and 2, 4. So here it becomes 2 and 4. We like just we saw here. It's, remember that when it's a 1, it'll be a 1, then a 2 and a 4. So it's like, so it'll be, so it's going to be 1 and 1, then 2 and 4. Right. Now it keeps going, but remember that it's the value is x is less than or equal to 2. So x is less than or equal to 2, so it ends here. Then from on this other side it keeps going, so we can just join it. So it's going to be it'll be like this. Then we know that the minus 2 would have also given us 4, so we can like this. Okay, this is for the first one. Then we know that it doesn't pass 2. Okay, it doesn't pass 2, so I should remove this. It ends here. Okay, this is where it ends. Then now what is starting? The graph of 6 minus x. Graph of 6 minus x. What is it now? We have 3 and 3, 4 and 2, 5 and 1. So it's 3 and 3, 4 and 2, 5 and 1, something like this kind of. So here now, what would we have? We just take a ruler. For a line, you need only 2 points. This is a line, because if you see the power of x is just an x, it's not even an x squared. So it's 6 minus x. So that means that it will be a straight line, which is nice. So we can do this and we can put a straight line to say. So here, this is where it keeps going to whatever value we don't mind. Okay, so it's like this. All right, so this is what we have, and this is the final thing, and this is the graph. Now, we want to check our limits using this solution, which we have worked so hard to get to. Now, we want to see the limit as you go towards, so part I, the limit as x goes towards 2 from the left of f of x. So x is going towards the value of 2 from the left. So here I'll be going towards this. So we are going towards 2 like this, okay? What y value are we approaching here? So here what do you have? So as I am approaching x value of 2, my limit, the solution of a limit is what y value are you approaching? So you can see, one thing we know is that this thing, I'm going towards 4 as I'm going towards 2 because it's curving up. Okay, so that is what you do. This is going to be equal to 4. That's the y value. Then we'll now say the limit as x approaches 2 from the right. So now what would we have from the right of f of x now? So what do we do now? Here we just try to see where it's going as we come from the right of 2. If I'm going towards from the right of 2, I'm moving like this, which means you'll be having to follow it, and it goes to a political pattern. So that is what happens. We are, if you see here, we are still going towards 4. Okay, now since both of them have the same limit, we can now say the limit so here it would be now the limit as x goes to 2 of f of x. And this now is just going to be, since from the right and from the left, since from the right and from the left you have the same, so you can now say, you can first put a line to say here, you want to now answer, this is part I. Now you want to answer I. You can say, here, you can now say, since limit as x goes towards 2 from the left. Okay, since limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right. Okay, this is going to be now, this is now going to be equal to 4. That's the limit. So that means this limit is just a 4, and you're done. So here it's going to be 4, and this is going to be your final solution, and you'll be done. This graph thing is so easy, it's not even hard. Let's go and do the next one, and we'll see where it goes with us from there. Goodbye for now.